Okay, so today I'm going to talk about microservices the TIDB way, and I'm Liquan Pei. And here's something like about myself. I'm currently working as a database engineer in PingCAP, and I'm working on TIDB, obviously. And prior to joining PingCAP, I have been working at Pinterest and Confluent, working on Kafka and Spark. And I know that Kafka is a project that started like 10 years ago, and it's still pretty active. You can see there's definitely complexity there, like doing something like Kafka from scratch. Because when Kafka is built, there's no distributed database that they have to do those from scratch. That's definitely take time and take manpower. I think I want to ask a quick question about maybe to you guys. Based on my background, how many years of SQL database experience do you have before I joined PingCAP?
2.
1 year.
0.
Actually 0. In my previous job, I have never used a SQL database. So the challenge is that I'm thinking that may be a cool thing because I have to create a lot of like services or code that actually do things that the database is supposed to do. But that's the reality in my previous 3 jobs.
What did you use instead of SQL?
I have used NoSQL databases like HBase. I've also used Kafka a lot. I've used Kafka as a key value database as well. So, but if you do that, you do need to create a lot of like abstractions on top of the low-level primitives. Yeah, so that is reality. So then let's get started. So I think microservices is pretty popular these days, and a lot of like famous company you have heard of using microservices. And these are the point-in-time topologies of microservices within Amazon and Netflix. You can see them now. But that's also testify that microservices already solving the problems. I think one of the million-dollar questions in microservices is how to do the data infrastructure or the databases. And there are 2 popular ways to do this. And the first one is one database per service. And the second one is actually shared database for the services. And there are pros and cons both approaches. For the one database per service, it is pretty easy to scale up. And you also have the flexibility to choose different type of databases with different services. But you also have some challenges. You lose the transactionality across different databases, but your application probably need that. And for the shared database, it's simple. You can actually take advantage of a lot of nice properties provided by the database. For example, transactions. For example, you can join data that power different services to provide you some insights. Those are pretty good. However, that also has challenges. I think the goal of building microservices is to deal with the scalability problems. But what if your database cannot scale? Then what's your solutions, right? So let's, to further demonstrate this idea, I'd like us to build an application together. And the application we want to build is open source software insight application. We want to take the events from the user interactions in GitHub and build a real-time insight on top of that. And the questions we care about are who are GitHub stars? And this is pretty useful for recruiters, right? I think probably your company recruiters will want to look at some body's GitHub file and figure out whether he's contributing a lot, whether he's contributing some cool like open source project. If the answer is yes, you probably want to carry them. And the second question probably are useful is which repositories are popular. Imagine that you are an investor, you probably care about which one taking off recently. And from there, you can potentially find some interesting like investment opportunities. And the third thing is also, we want to understand which GitHub superstars are following a specific repository. This is also very useful because as an investor, you may want to look at which are like the top stars or superstars follows, then you probably can figure out some hidden gems of product. I will pause here now and how are we going to solve this problem? What architecture are we going to build to solve this problem? Based on these three probably simple requirements.
ClickHouse.
ClickHouse? Any maybe easier solutions?
Redshift.
Redshift? Okay. Snowflake? Okay.
MySQL.
Okay, MySQL. Yeah. I think maybe let's before I go there, I want to talk about the data first. So we'll interact with GitHub. So you can watch a repo, you can fork a repo, you can start a repo. And each actions will create events. And the events has the type and also the repo name and who is making those events. And currently this about has 4.6 billion like events. It's also growing very, very fast. I think each day you will have like hundreds of thousands of events generated on a daily basis. So it's already a big data set and it's growing in a relatively fast speed. And how are we going to solve this problem?
Absolutely, we cannot put 4.6 billion into single MySQL because the index length is very steep.
Yeah, I agree with you. But let's maybe simplify this a bit. Let's assume that we don't have 6.4 billion events. Let's simple that we build this application from day one. I think how are we going to do it, right? We're going to build an app with a database. I think that is many people's first choice. It's pretty simple. But then let's assume we are using this architecture. How are we going to maybe answer this question? Assuming we're using relational database, well, we are using an app. This is a probably simple question.
So you're going to run a SQL query,
Yeah.
What's the database? Or if it's a document-based database, I don't think you can even serve this query.
Yeah.
But you'll run a query, select from that user table.
Yeah.
Is the user GitHub superstar? Yeah. I mean, you'll check essentially, right?
Yeah, maybe
you'll put some more aggregation.
Select star
some predicates.
Table where username equals to.
Yeah, it's pretty simple, right? It's like const star from the table and then have a predicate there. And we finish this query probably in 10 seconds. So it's quick. Yeah, no brainer. Yeah, let's go to the second question. Which repository popular? Any volunteers want to write a query on this?
Select star where database specific the database's stars are greater than whatever the delimiter.
Yeah, sure. So I think maybe let's first define what I think one way to define a repository is popular now is to count the number of like events on certain repo, right? A number of stars, number of forks. So I will simplify a little bit. We can basically do select count group by, right? And then figure out whether the count is hitting a threshold. So this is a little bit complicated, but I think we can figure out within 30 seconds, right? So no brainer as well. Yeah, let's make something fun. So which GitHub superstars follows a specific repository?
Okay, so subquery.
Subquery? So
Join.
Okay. Any other volunteers? Your thoughts do not be SQL queries. How do you want to solve this problem? Yeah, this clause is good one. Yeah.
Right.
So there are multiple ways to solve this problem, but I think on a high level, we can start with figuring out who are the GitHub superstars. And that can be done through a subquery. And from the subquery, join the event table again and figure out who they are following. They are following specifically. And the query is something like that. So it's a bit complicated, but I think personally, I'm not, imagine I have zero experience of written SQL, and it takes me about probably 5 minutes to write this query, but I think you will do better than me in this case.
Optimizer.
Anyways, I spent probably 5 minutes, but you guys can done in 1 minute. I think these give you a sense that to build such application with SQL is probably pretty fast. I think if this application only have this 3 functionality, you can probably finish all the business logic within a weekend, something like that. But then we typically have the happy problem is that you have growth. So your user base may grow. And this is good for maybe the engineers or the founders of startup, but it's also cause problem for the database. I make a simplification when we design this application. We ignore that the fact is at 4.6 billion records and it's growing in a relatively fast speed. And it definitely cannot be handled by a single traditional MySQL database or Postgres. And as more and more even join and more users using this application, the load on the base is growing and the database become bottleneck of the application. Then how to scale? How do we solve this problem? I think a typical way of solving this problem is through sharding. And sharding is pretty simple. You divide your database and put it into multiple database instances. Yeah, a sharding key. Yeah, sharding key. You can write your own sharding middleware, but I mean, you can also do it on your own, right? And then let's come back again to these three simple requirements. So in case of sharding, let's assume that we're sharding by the user key, user ID. What would be the query look like to figure out whether user is the GitHub superstar?
You mentioned that you choose the sharding user ID.
User ID is the sharding.
Okay, just the same.
The same? Any objections? Objections? Yeah, let's. Yeah, so we can use the same thing, right? We figure out the count, right? And we do because all the data because we shard by the user key and all the data belong to a single user will be within a single shard. And then we just need to select count star. Let's come back to the second question. Which repositories are popular? Okay, how are we going to solve this problem in the context that we shard the database by the user ID? That's assuming that we may have like 10 shards, something like that. Any volunteers want to write something here?
I say it's forecasting.
So now your query has to do the aggregation on multiple shards.
Yeah, do that for sure.
Because your repositories are your users are basically distributed on the shards.
Yeah.
So you want to maybe union of all the shards.
Yeah, that's a good question. Good insight. So definitely you cannot solve that by a single SQL query, right? You need some control logic in the application. And this is a pseudocode. It's something Python, Go mix, okay? Everything on that. So basically you need to loop all the shard, and for each shard you send the query, figure out who are the popular ones, and then merge the result, figure out the global popular ones. So that is basically this logic. It's already getting a little complicated. You need to think about it. You also need to verify whether this is right or wrong through tests and through releases, right? And third one, which GitHub stars follows the repository? How are we going to solve it?
The first loop is to forecast and get a superstar.
Yeah.
And all the user ID. And then you write application for loop is all the GitHub of the stars and send the
Okay. So it's hard, right? It's GitHub is our CTO. So definitely it needs some thought, right? I mean, definitely some thought, right? You probably need to sketch, maybe sketch a little bit, write some diagram about how things are shared, how data are distributed. And you also become less confident about the code you write. Yeah, I'll put one solution. There are multiple solutions to this problem as well. The first one is can you see this clearly? Okay. So basically is need to figure out the local top GitHub superstars, and then we need to merge to figure out global superstars. And then it's not enough because we also need to know that which shard is top within the top the GitHub superstars are from, so that we can send those users to figure out whether they are following a specific repo. So it's a two level of like scatter gather, and it's more complicated. And also this is once you write this code, so you see the problem. You basically lose the transactionality of SQL, right? You also need to handle a lot of failovers. I'm not sure how many people have used sharding, or how many people have done sharding before. Okay, cool. How do you like it?
Not very cool.
Okay,
We haven't manually implement all the sharding middleware.
Yeah.
Over.
Yeah, I think I just through three simple examples, I just demonstrate already. You can see the complexity of sharding, and this is only the tip on the iceberg. So there are many more issues with sharding, and I'll read out them loudly. So you need to handle the shard failover manually, and the scale in, scale out of sharding is downtime, and also schema changes after sync, and you lose transactions. And your application needs different keys, and you probably need resharding if the application really needs to change, and many more of them. And how do we solve this problem? So for today's business, because time is money, basically, right? If you use sharding, your business may move slowly. And how do you solve this problem? And we have this TIDB rescue, okay? And what is TIDB? I think Dongxu already mentioned that TIDB is, and you don't need to do manual sharding with TIDB. And this is MySQL compatible and horizontally scalable. It is highly available. It supports ACID transactions and strong consistency. It is open source and cloud agnostic. So actually, the application I just mentioned, we actually build one. We build one. This is a real application. I just take three probably simple functionalities from this application, and I will now do a real-time live demo on the application we built.
Actually, now GitHub is keep pushing their public events in real time. So I'm thinking, why not we gathering all the think about GitHub as the Kafka, keep pushing the events out of GitHub, and why not we get all of these events? Right?
Yeah, the data is actually in real time. You can see the changes of what's happening now on GitHub, and also the number of events in real time. Okay, so let me do a quick live demo, and I want to ask Ad. Sorry, what is your favorite open source software? Kubernetes. Okay, cool. Kubernetes is really popular. So let's see. So we basically build an insight for a repo, right? So in the demo application, we just showed which repo is regular, but here we want to show many detailed insights on Kubernetes on a certain repo. So do you know which country contributes Kubernetes most? What's the result?
United States.
United States. Okay, cool. Let's see. Okay. Actually, it is correct. It is United States that contribute most PRs to Kubernetes.
But I think this Stargazer. Oh, okay.
Yeah. Stargazer is a little bit different, right? You can see that most people in China cares about Kubernetes. They have the most stars. But from the pull request perspective, United States has more pull requests. I think the second question for you is that which company contributes Kubernetes most?
Of course, Google.
Okay, Google. Okay, so let's see that. Okay, that it's roughly similar with Google and Red Hat, right?
Yeah.
Okay, I think this is really interesting because I thought investors may want to understand why Red Hat contributes a lot to Kubernetes. There may be something you want to know. Yeah. Okay, and the whole thing actually is built on by SQL. You can see if you understand which country contributes or which company contributes most on Kubernetes, we just write the single and also for other functionalities. I want to mention that this application is built by 2 developers in 2 weekends on TIDB. And I think this is good for the PMs to, as they want, when they want to add more requirements, it can be easily satisfied by writing more SQLs, so which can be very fast. Yeah. So the traditional way of building this application is a bit different, actually. Obviously, you probably need Kafka to get the data from GitHub, and then you do some ETL pipelines to dump the data to data warehouse. And you probably also do some internal processing to write the data back to the database for storing. And this is rather complicated. Not to mention that the ETL pipelines is pretty hard to maintain. And also you have the cost of paying the different systems. And with TIDB, you can use a single database to do this. And I'll talk about what TIDB and Flash and TIDB about. But for this application, this is the backend architecture. And you can see the only TIDB, and it powers both the web services and all the real-time dashboards. I want to quickly go through the TIDB architecture. It is a layered architecture. And from the application product perspective, it speaks MySQL web protocol. You can use a MySQL client to connect it. And it roughly feels like you're working with a single node database. But under the hood, we handle the data failover, scale out, scale in, and parallel query processing. And all the disadvantage sharding is handled by TIDB. So TIDB actually handles all the complexities. And from the application perspective, you can use SQL, you can use all the secondary indexes to handle the complexity of your application, even as the data grows, as the user grows. So you don't have the problem of the heavy growth problem. So with TIDB, and you don't have to make a trade-off between one service per database or the shared database. You can use TIDB to power any microservices that is scalable, and it is easy to use. Any questions on this? TIDB?
How to do the resource isolation?
Sure. There are like TIDB in TIDB 6.0, and it offers a new feature called placement rules in SQL. And the idea is that you probably need some like isolations on different services. And one way to do this is through data placement rules API. It offers functionalities to place database, table, and partitions into dedicated resources. And the way to use it is pretty simple. And we can just add labels to the storage servers. For example, in this case, we create a node pool and try to support service 1. And then we can create a placement policy. And with the constraint that this service 1 will be only put on the service 1 pool. And then when we create this database will be using this placement rule. And all the data in this database will be placed on the pool of service 1. So that gives you physical isolations so that different services will not share the same TIDB service. And this has not only can be used for resource isolation, it can also be used to do like geopartition. You can create services with, you can label the TIDB servers with geolocation, for example. It can be in a different availability zone or in a different region. And so that once you apply this policy, some of the data will only be available in a certain region or a certain availability zone. And the other way to do this is to use hot kind of like warm data separation. For example, some pools can be provisioned by hard disk. Some pools can be provisioned by the SSD. Then once you apply the services, some of the data will be in the hard disk, some of the data will be in the like SSD to separate, to reduce the cost of our system. And I think basically the TIDB way of handling microservices is through its own capability of scaling, so that you can use a single database to handle many services. If you need further like resource isolation, actually TIDB provide a placement tool for you to do that, and it's pretty easy to use. So I think this concludes my talk. And if you want to know more about TIDB, I think the best way is to actually give it a try. And we provide the TIDB as a managed service, and you can sign up for free and try it out on your own to see what happens in action. If you are interested in using TIDB in production, you can also apply for POC, and we offer the production level support. And here are some more information on TIDB, and we have the blogs. You can read more about the internals, use cases of TIDB, and then it's open source project, and you can join the Slack channel to discuss internals and applications on TIDB. Yeah, that's all my talk.